Hello, welcome to all. I hope that you are enjoying the lectures and you are studying. If you have not watched the previous sessions, please watch. Okay, then you come for this current session. Today we are going to learn pointers. So many of you pointers means is very uh, people have created a hype on pointers. Okay, it's a very simple concept. Okay, understand it. It's very easy to solve, but focus. Okay, focus on it and you can solve the problem. Before we understand pointers, first we'll understand how my program is working. Okay, I wrote integer x. By writing, what happens? You create a memory. You create a memory. Where you create a memory, where you allot a memory. What are the memories I have? Okay, I have a hard disk, it's a secondary memory. Then we have a RAM, we have a primary memory. Okay. Then we have a ROM, which is read-only memory. Then we have our registers. Now, when you say integer x, the memory for this variable will be allotted in the primary memory. You know how many bytes have been allotted, right? How many bytes have been allotted for this variable is 4 bytes. Okay. Now, when I internally understand how the memory works, I am assuming my memories are one block. I wrote like this. Each block in my RAM is what? 1 byte. I am drawing a byte by byte. Every byte in my RAM is being identified by an address. I'm assuming the address of this byte is 115. I'm assuming, okay. The address of this byte is 116, 117, 118. 119, 120, 121, 122, 123, 124, 125, 126. This is what I took one segment of my memory. Okay. When I write it in this place, integer x, for x, 4 bytes have been allotted in my memory, in my RAM. 4 bytes have been allotted in my what a byte can store, you know very well. What a byte can store, 1 or 0, right? A byte has 8 bits. A bit can store 1 or 0. If I write integer x, there are 4 bytes. 4 bytes means there are 32 bits are there. Correct? Now, I am assuming when I wrote integer x, the 4 bytes is allotted, right? The next is when I write it in this place, integer x is equal to I put it in this place. I'm going to write it in this place 7. When I write integer x is equal to 7, what is happening? The binary form of 7 is stored in my memory. What is the binary form of 7? Actually, the binary form of 7 is 111. Right? 111 is only 3 bits. That means this starts storing from right to left 111. The remaining all bits are filled with zeros. All bits are filled with zeros. 000. Remember? And then you know the first bit is a sign bit. Integer x is 7. 7 is what? Is positive. Therefore, the first bit is what? 0. Is what stored. Now, whenever I write a variable x in my program, I wrote here, let's say, printf percentage d, I put x. When I write printf percentage dx, what is happening? Whenever I refer a variable, it goes to the memory. It goes to the memory. How it knows the memory? Okay. How it goes to get the memory, we'll come to know. It goes to the memory and gets the binary form, and then it prints the binary form in the decimal form. Therefore, I got 7. Prints the binary form in the decimal form. Okay. Now, how it went to that memory? Because so much of memory is here. How it went? Yeah, we are going to see. If I say here in this case, and x, whenever I refer a variable with an and before, what it does? It goes to the variable and gets the first address of it. What is the first address? Is 115. It is not going to get all the four addresses. It's going to get only the first address. The first address to a variable is called as pointer to the variable. If you want to print this, what I should do? Use percentage u. Why u? Because an addresses are always unsigned. You can never find the address negative. Percentage d is for signed integers, unsigned integers. Now, when I write here in this place and x, you get the address. First address, correct? If I put a star before it, what it does? From the first address, it is going to read 4 bytes. Why 4 bytes? I'm going to come back. From the first address, it's going to read 4 bytes and it's going to bring the 4 bytes, whatever the contents of the 4 bytes is going to come. The contents of the 4 bytes is a unsigned integer, therefore I put percentage d. If I do it, I'm going to get 7. You know, by putting percentage d, you are converting what? The binary into what? A decimal, right? This operator is called indirection operator. Indirection operator. Indirection. This is called address of operator. This is called what? Address of. Address of. Address of. Okay, I wrote singly. So whenever you put an and before a variable, you get the address. First address, not all the address. Whenever you get a star before a first address, it is going to read from the first address 4 bytes. Why 4 bytes? Because this 115 is an address of type what? An integer. Got it? Yeah. Yeah. Okay. Now the next is here in this case is, see, I would highly appreciate if you take your notebook and write whatever I did say, okay? Because when you write it, it registers in your head much better, okay? This is my request to you. Do it, okay? Now, so we said, when I say x means I'm going to get 7, okay? If I want to store the value of x, what I need a variable y. Correct? I can say by saying y, yes, you get 4 bytes. Sir. You also get 4 bytes here. How it is referred as y? By saying y is equal to x, you copy the binary form of this into this. After copying, the x and y have no relation. That means if I say here right now, x is equal to 5, the binary form of x will change, not the binary form of y. Why? Because they have no relation. Now, what is the binary form would appear in my this one would be, it would be a binary form of 5 is 101, correct? 101. Stored, right? Okay. Now look at this. If I say here x means I'll get the binary form of 5. If I want to print it, I'll use percentage d and say x. What will get what? 5. If you say y means what will get? I get what? 7. Because x and y have no relation. Okay, sir. Now I wrote right now like this. What I wrote was, I wrote here right now. I wrote here in this place and x. When I say and x, what I'm going to get? I'm going to get the first address. I want to store it. Oh, I want to store it, store it. Where I should store it? You should store it in a variable. This variable must be a special variable. It is called pointer variable. By saying integer star p, You create 4 bytes only, sir. But what is the name of this 4 bytes is P only. The name of the 4 bytes is not star P. Sorry. At the line of declaration, the star will be always associated with the data type. It is called integer pointer. Then what is a pointer variable? A pointer variable is a variable that stores an address of another variable. That stores an address of another variable. Remember, a pointer variable is a variable that stores an address of another variable. Writing P is equal to index, what I did, I store the binary form of the first address of the whole. In this 4 bytes, the binary form of the first address binary form is existing. Okay, I wrote 115. Okay, sorry. It should be the whole byte. I need to write the binary. I'm not writing. Sorry. Okay, sir. That means if I say right now, P means what I'll get. When I say P, I'm going to get the content of this variable. What is the content of the variable? It is not a value. It is an address. If you want to print it, you should use percentage U. I'm going to get 115 in my example. Okay, remember, you may get something else. Address, I don't know. Now, when I say here P means I get 115, if I put a star P means what I'm going to get? I'm going to get the whatever the content inside the 115 will be read and will be given. What is the content inside the 115 is going to be? It is the 4 bytes. What is existing? What? 5. If I put percentage D, I put 5, I'm going to get. Now you need to understand. In my register memory, remember I talked about the last register. There are 2 types of registers. One is to store a value, other one is to store an address. In the address register, what are the 2 type of register we said? One is a value register, other one is an address register. In a value register, you can only store what a value. In address register, you can only store what an address. In a value register, I can't store an address. In address register, I can't store what a value. Okay, what is the meaning of this statement? Now look at this. So I write here in this place, let's say in this case is x plus 2. So this is an expression. This expression will be solved. By whom? By the registers. First is x value will be brought from the RAM to the register. 2 will be copied into another register. When I add both of them, I'm not going to add the decimal form of it. I'm going to add the binary form of it. After adding the binary form, the result will be copied into another register. What would be the type of the register? Is a value register because you added 2 values. If I get what? 7. 5x is 5. Now this register value can only be copied to an ordinary variable. You can copy to y. You can't copy to p. Why? From a value register, you can never transfer to a pointer variable. From a value register, you can transfer only to a value variable. Now, if I write here in this place and x, I'm going to get the address of x. This is an expression. Where is this expression stored? In a register. But what type of register? Address register. From the address register, you can copy only to a pointer variable. You can never copy into an ordinary variable, not possible. You can copy only into what? A pointer variable. Remember, from the address register, you can only transfer to what? To a pointer variable. From an ordinary register, you can transfer only to a ordinary variable. Okay? I hope that you understand the concept of registers. Okay? The operation happens only in registers. There are 2 types of registers. One is a value register and an address register. Whenever you deal with the ordinary variables, it will go to the value register. The result of the value register can copy only to ordinary variable. It cannot be copied into a pointer variable. Okay. Now, when I wrote here in this case and x, what it does? It gives me the first address. What it gave me? 115, which is stored where? 115 stored where? 115 means I talked about this. 115 stored where in a address register. But if you put a star before it, it will transfer the result to the value register. It will read from that address to this. I'm going to get right now in this example 5. Why? Because my X is holding the binary format. The same way, when I put P is an expression, but the expression produces what? It produces an address. Why? Because the content of this is an address. If it is an address, it will be stored in an address register. When you put a star before the address register, what it does? From the address register, from the address, it will keep on reading 4 bytes because it is storing an address of an integer. Therefore, when I wrote star P, I also got what? 5. If I write X also, I'll get 5 only. Correct? X also 5, this also 5, this also 5. That means all these are referring X only. Your X can be referred either X and X star and star P. Remember, whenever you put a star before a pointer variable, the result will be stored over in a ordinary registers. Okay. I hope you understand. Okay. Therefore, now what is a pointer? A pointer is nothing but the first address of a variable. The first address of X is 115. Therefore, 115 is a pointer to X. The first address of Y is what? 119. 119 is a pointer to Y. And first address of P is what? 123. 123 is a pointer to what? Therefore, a pointer, the first address is called as a pointer to the variable. What is a pointer variable is a variable that holds a first address. That holds a first address of another variable. Okay. Got it? Therefore, now let's solve a problem. Okay, let's solve a problem and understand. Okay, how it is. I'm going to take a simple example and solve it. Then we will see whether you are able to solve it or not. Certain problem. Then we will take it ahead. Okay. Let's say 5. And I have written integer pointer p. That's what I've done. I created and I've made one. Let's say for you also y is equal to 7. 7 ka binary form. Now I write p is equal to and x. And x means what I want to get? Address. Address will be stored where? In an address register. From address register where I can transfer to a pointer variable. Right. Now if I say here x means I'm going to get 5. Y means I'm going to get what? 7. Okay. Now see, for you to understand better, I'm not going to put the binary form. I'm going to put what? The decimal form. Okay. This will help you to understand a little better. I put right now like this. Okay. X is right now what? It is 5. I tried Y 7. It's in 4 by 3 as well. Now look at this. I am going to write here in this case P. P means what I get, sir? P means I'm going to get what? 115. This. Content of this. Content of this, right? Where is P stored? P is stored in a address register. Remember, from a pointer variable we transfer to an address register. From ordinary variable we transfer to a ordinary register. Okay. Now look at this. I'm going to say here in this case star P. What I'm going to get? P is holding 1 on 5. Star P is holding what? How much what? 5. Now I wrote it in this case. Star P is equal to 25. Can I write this? Yes. Why? When I write star P, what I'm talking about? P means I'm talking about this 1 on 5. Star P means I'm talking about what? Content of 1 on 5. Star P means content of 1 on 5. P is 1 on 5. Star P is what? Content of 1 on 5 is going to become 25. Done. Sir, can I say P is equal to 40? No. Why no? What is P? P is this. This is a pointer variable from a ordinary register. From ordinary register, you cannot transfer to what? To a pointer variable. So then can I say P is equal to 115? So 115 is an address. No, you can't say. Why? Address cannot be generated by you. Address can only be generated by address of operator. Only address is only given for variables, not for constants. Remember. Okay, now next is. Now if I say here, can I say star P is equal to 35? Yes, why? When I say star P, I'm referring whom? P means I'm referring 115. Star P means here it goes to 30. So after this statement, if I write here in this case X, how much you should get? X is holding what? 35. Correct? What if we say Y? Y is holding what? 7. Same. What about if I say P? P is holding what? 115. Remember, 115 is an address, it is not a value. If I say it in this case, star P, how much I want to get? 35. Why? P is 115. Star P is a content of this. I get what? 35. That means if I ask the question, what is X and star P is giving 35. Why? Because X and star P refers the same memory location. But P refers a pointer memory location, whereas this refers what? Okay, sir. Now I wrote like this. Okay, let's say in this cases I have written right now. I wrote here in this case P following. Okay, P is equal to and Y. By this, what you are going to do? Okay, and Y means what you are going to get? This is 119. Y means what? This 400. And Y means 119. You think the same, I'm not writing 9. That means if I say X means what I'm going to get? 35. Y means what I'm going to get? 7. Now, P means what I'm going to get? 119. That means if I say star P means how much I'm going to get? I'm going to get 7. Why? P is 119, star P is this 4 address. In this 4 address, what value is stored? What? 7. So that means if I say star P is equal to 40, where the 40 is going to be stored? Yeah. P is star P means P is 119, star P is here. In this 4 bytes, 40 is going to be stored. That means if I say X means after this statement I get 35, Y means I'm going to get 40, and P means I'm going to get 119, star P means I'm going to get what? 40. So the question comes to me, sir, why do I need to use a pointer variable? Why? Why do I need a pointer? So I agree, pointer variable holds an address of another variable. I agree. But why do I need to use? A pointer variable will help you to access a memory location without using its name. A pointer variable will help you to what? Help you to access a memory location. Access a memory location without using its name. Without using its what? Name. What do I mean by this? What is the name of this memory location is Y. But how did I access it? I said star P. No. There's a first use of a pointer variable. The second use of a pointer variable is using a single name, using a single pointer variable, I can access multiple memory locations. See, here when I wrote star P, it referred what? X. Here when I wrote star P, it referred what? Y. Because here P was storing the address of Y. Here the P was storing address of what? X. Therefore, the simple thing for you, the second reason for using a pointer variable is to access multiple memory locations using a single name. Using what? A single name. That is the purpose of what? A pointer variable. Okay. So let's recap. So if you like my session, kindly share, subscribe, and like. What is a pointer? A pointer is nothing but the first address. First what? Address of a variable. Okay. It is called as what? Pointer. Remember pointer. What is a pointer variable? Pointer what? Variable. It holds a pointer. It holds what? A pointer. How do you declare a pointer variable? By declaring it in star. At the line of declaration, the star is not with a P, star is with an integer. Now, why do we use a pointer? To access a memory location without using its name. Correct? What's the other use you said? You can access multiple memory location using a name, using the same pointer. Okay. Therefore, a pointer will hold only for an address. Okay. Next, we talked about two type of registers. One is what? A value register, other one is an address register. A value register will hold only a value, and address register will hold only what? An address. From a value register, you can transfer value to ordinary variable. From address register, you can transfer only to a pointer variable. Similarly, from a pointer variable, you will always transfer to address register. From ordinary variable, you always transfer to what? To a value register. Okay. Okay, guys. Now what we are going to do? I'm going to give you a problem. You are going to write the problem in your notebook, draw the blocks like me, and then what you do what? Then you solve the problem. Then you come back if you are not able to solve the problem. But you should be able to solve the problem. Okay? Understand and solve. Okay? So draw blocks like me. I wrote integer x is equal to 25. Integer y is equal to 32. Integer pointer p is equal to 100. You can also write at the same line, but I'm not writing now. Okay. Now I write star p is equal to x plus y. After this statement, I want the output of x, y, and star. Okay. Then I wanted what I wanted. I'm going to say the same thing. Okay. P is equal to and y. I want to say star p is equal to x plus y. I want the output of x, y, and star p. Okay. Please write on your notebook. Please write down, draw blocks, solve the problem. We'll see what is coming. Okay. Make an effort. Okay. Pause the video. Don't try to watch the video continuously. Pause the video. I hope you will have made an effort. Okay. Let us see here. Okay. Now let us see what is important. Okay. I'm going to draw blocks. I'm going to draw 4 blocks. I'm going to go address. I put my any number you put us. 7, all but in a sequence. Okay. For 4 bytes. You can't put random numbers. So let's assume this is for x, this is for y, this is for p. Okay. So now what do you do? Put values inside, manipulate it. So pause the video and do it. Okay. Okay. I hope that you all have solved this problem, right? Let us see what is the answer is coming. Okay. Let's say what he wrote. He wrote the integer x is what right now. In this example, he wrote x is what? 20. Correct? 25 stored, the binary form of 25 stored in 4 bits. Why is 32? P is AND X. What is stored? 115. So X plus Y, how much it becomes? 25 plus 32. How much what? 57. Correct? 57 is stored in star P. What is star P? P is how much it is what? 115. Star P means I am talking about this. How much is stored what? 57. Hmm. X means I am going to get what? 57. Y means how much I am going to get what? 32. Star P means I am going to get what? P means 115. Star P means how much what? 57. P is AND Y. AND Y means what I get? 1 1. X plus Y. How much it became? X is 57. 57. Remember, X is not 25 because X is new value of X you need to take. This is 32. Right? 57 plus 32, how much what? 89 is stored in star P. What is star P? P is 119, star P is here. How much I should store what? 89. Now I wrote X. X means how much I'm going to get? X is 57, right? See, I look here. X is 57. Y is how much what? 89. And star P is how much what? 89. Got it, guys? Yeah? Okay. So if you have solved it right, very good. If you have not solved, once again revise it and go for the next problem. I'm giving next problem. Okay. From ordinary variable, you can only transfer to what? To a value register. From address variable, you can store only to a point address register. Remember. Okay. Remember that whenever you write. Okay. Whenever you write any expression, right hand side is always a value, left hand side is always what? A variable. Remember. Star P, star Q, and star R. Now I write P is equal to index, Q is equal to and Y, and R is equal to and Z. Right? Now I write here, see, I'm going to write here in this case P is equal to Q. You know what I'm doing? By writing P is equal to Q, right hand side, right? It will be copied, the right hand side will be copied into a register. Now, Q, whatever the address of, what is the address stored in Q, that is the address of Y, is going to be copied into a register and is going to be transferred to what? P. Remember, transferred to what? P. Now I write here, Q is equal to R, R is equal to P. By writing R is equal to P, the P is not having the original value of original values, having the value of what? Q. Remember that. Okay. Now I write here in this case, star P is equal to star P plus star Q plus star R. Okay. Write this down. Okay. Non-stop. Then I write here in this case, I'm going to write here P is equal to Q again, Q is equal to R again, and R is equal to P again. And again I'm going to write star P is equal to star P plus star Q plus star R. Now I write I want the output of X, Y, Z, star P, star Q, star R. Okay, I want this output. Go, write in your notebook, get the output form. Okay, pause the video. Sincerely do is very, very important concept for the following topics. Okay, if you don't understand this, your arrays will not understand, your functions will not understand. Therefore, better you solve the problem sincerely. I hope you made an effort. Okay, hope made an effort here. So let us see what you should have got the answer. Okay, what I would have done now, I would have made a variable called x. X is how many bytes? 4 bytes. Okay, I'm writing 4 bytes to the 119, sorry, 115 to 118. Now this next 4 bytes starts with what? Y is 119 to 123. No, 122. This would have been Z. How much? 123. Right. Now you create a variable called P, Q, and what? R. This is how much? What? 1. I put 127, 131, right? And 130. I put. Now my x value is 7. So what I need to do? 7 is stored in the binary form. Y value is 3 is stored in the binary form. Z value is 2. P is and x. What I stored? 1. Q is and y. How much? What? 119. It is 1. R is what? And Z. How much? 123. Now I say P is equal to Q. By saying P is equal to Q, what you've done, whatever is in the Q is going to be copied in P. That means this is go away. What is going to come in that place? What? What is going to come in the place? What? 1, 1? No. Correct? No. Q is equal to R. By this, what had happened? In this place, whatever is here will be erased. R value will be copied into what? Correct? That means I copied here 120. R is equal to P. What is what you are doing? You are copying the P value in R. That means what is in P right now is not 115. It is what? 119 because it's already lost the value. Now write star P. What is star P? P is 119. Star P means what? 3. Q is 123. Star Q is what? R is 119. Star R is what? 3. 3 plus 2 plus 3. How much? What? 8. 8 should be stored in star P. Star P means where I should store P is 119. Here I should store 8. Remember, it's 8. Okay. Now I wrote P is equal to Q again. But what are you doing? P is equal to Q means what you are doing? Q is right now what? 123. You are going to bring the 123 in the Q is equal to R. What you are doing? By saying Q is equal to R, in this place what you are putting what? 119. Remember. And R is equal to P. By this what you are doing? You are shifting what? 123. Correct? Now I write here star P. Star P. P is 123. Star P is what? 2, sir. Q is what? 119. Star Q means how much will get what? 8. R is how much? 123. Star R means how much will get what? 2. That is 10 plus 2 is 12. 12 is stored in star P. What is P? 123 is stored in 2. Now what is my X is? X is 7. Original value. It's never changed because we changed that first itself. Y is how much? 8. And Z is how much? 12. Star P. What is star P would be? 123 is pointing towards what? Z. That is again 12. Star Q. Q is 119. Star Q is what? 8. Star R. R is how much? What? 123. Star R is what? 12. Right? Therefore, now, remember, these two are same. Why? This is holding the same address. Yeah? Okay. Now, I am going to write the same thing but in a different way. You need to get the output form. Okay. I wrote the same thing but I made some few what changes. Okay. Look at this. What are the changes in? Instead of writing the Q is equal to R, I wrote star Q is equal to star R. I can't write star Q is equal to R. Remember that I can't write it. Okay. Why? Because R will give an address. Star Q will refer ordinary variable. Next here I say star P, star Q, star Q, star R, star R, star. Correct? So I made all star before. Rest all same. Okay. Now go and get the output form. Okay. Write it down. Slowly write it down. See this. Scroll. Okay. Write in your notebook. Do not try to understand by visually and all. Nothing will work. Do it. Okay. Okay. So get the output form. Pause the video and get the output. I hope you made an effort. Let us see what is the output I should get. Okay. X is 7. Same. Y is 3. Z is 2. P is equal to and X. How much what? 115. Q is equal to and Y. How much? 119. R is equal to and Z. How much what? 123. Right. P is equal to Q. That is what you are doing. P is equal to Q. By this you are deleting here. You are putting 119 here. So here is something is hanging. You are putting what? 119 here. Star Q is equal to star R. Remember, star Q is equal to star R. Star R means what? R is 123. Star R means 2. 2 is going to be copied in star Q. Q is 119. And here what is going to be copied what? 2. R is equal to P. What is R is equal to P? P is how much what? P is 119. R is equal to P means what? I brought here in this place 119. Now look here. All are holding 119. Now I write star P. How much? P is 119. Star P means how much what? 2. Star Q. Q is 119. Star Q is 2. Star R is also 2. How much it becomes? 6. 6 is stored in star P. P is 119. Star P would be what? 6, right? Now, star Q is equal to star P. Q is 119. Star Q is 6, right? Is equal to star P. P is 119. It's the same place. Star R. R is how much? 119. Star R is how much? It is what? 6. It's going to be stored in star Q. Star Q means what? Q is 119. Star Q is this. Star R is equal to star P. Star P. Star P is how much? What? 119. Star P would be how much? It is what? 6. 6 is stored in the same place because all are holding the same address. Now, after this statement, I wrote star P. P is 119. Star P would be what? 6. Star Q is also 6. Star R is also 6. That means I write here 6 plus 6 plus 6. How much? What? 18 is stored in star P. P is 119. Here I stored what? 18. X is what? What is X? X is 7. Y is what? 18. And Z is how much? Star P. P, Q, R, all are 119. That means you get what? 18, 18. Okay. So if you have not got it, please solve the same exercise again and understand. We are going to solve more problem in the next lecture. Okay. We are going to understand more pointers. First is you get the grip of it. You get the okay. Got it? Yeah. Thank you.